Hello students, welcome back to our course e-learning mathematics classes. Today we are going to discuss some model problems on about basing on arithmetic progressions. Arithmetic progressions, that is the models on AP. Right. Now coming to the first question. If A1, A2, A3 are in AP such that A1 plus A5 plus A10 plus A15 plus A20 plus A24 is equal to 25. Then what is the value of A1 plus A2 plus A3 plus A24? You are given an AP series. Of course, some terms of the sum is given. Then you have to calculate the sum to first 24 terms of an AP. Right? Okay. The procedure is you are given A1 plus A5 plus A10 plus A15 plus A20 plus A24 is equal to 225. The meaning of this is, of course, these terms are in AP. The general point is the terms which are equidistant from beginning and ending of an AP series is always equal, same, and is equal to sum of the first and the last. Once again, this property of AP is the sum of the terms of an AP which are equidistant from the beginning and ending is always same and is equal to the sum of the first and the last. That means, A1 plus A24 is equal to A5 plus A20 is equal to A10 plus A20, A10 plus A15, which are all are same. Right. Now, because these terms are in same, then these terms, this expression value becomes 3 times of A1 plus A24, because first term, second term, third term, first, second, third, these are 3 terms. So 3 terms of each of any one of them, because all are they equal, that is given as 225. Now A1 plus A24 equal to, that is 75, and cancelling 75 times. Now we have this result. Our final target is finding the sum to first 24 terms of an AP. Of course, it is A1 is the first term and A24 is the last term. If you know the sum of first and the last term of an AP, you can calculate the sum to 24 terms, or sum to n terms of an AP is given by n by 2 of A plus n. Is the formula for sum to n terms of an AP when the first and the last term are known. Here, the first and the last term data is there. Therefore, we are using this formula for sum to finding the 24 terms. Sum to 24 terms is given by 24 by 2 of A plus L. A is here A1 plus L means A24. A plus value is this one. That is 75. It is 12 times gets cancelled. 1275, that is 900. So finally A1 plus A2 plus so on A24, sum to first 24 terms of the AP is given by 900. Right? Okay. Next question. We go to the next question. Right. Coming to the next question. Let TR be the rth term of an AP. If for some positive indices m and n, we have Tm is equal 1 by n and Tn is equal 1 by m. Then what is Tmnth term? Is the mth term is 1 by n, nth term is 1 by m. Then Tmnth term is required. Right. Now the procedure for the second question is you are given, of course, TR be the rth term of an AP. Let the first term of AP be some A and the common difference is D. Then you can write Tmth term. Tmth term is given as A plus m minus 1 into D. That is given as 1 by n. Formula for nth term of an AP is A plus n minus 1 into D. A is the first term, n is the common, D is the common difference, n is the number of terms, right? So using this result, mth term is given by A plus m minus 1. Here m is the mth term. Therefore, m minus 1 into d is equal to 1 by n is given. 1 by n is given. Now, similarly, nth term, t nth term is given as a plus n minus 1 into d equal to 1 by m. This value is given as 1 by m. This is given data. Now, we require t mth term. T mth term value. Of course, t mth term can be written as a plus m minus 1 into d. If you know a and d values, you can calculate mth term. Right? Now, we are going to calculate a and d value from these two relations. Right? Now, if you subtract the first equation and the second equation, then after subtraction a gets eliminated, then m minus n into d is there equal to 1 by n minus 1 by m after subtraction, or that is m minus n by mn is mn into d, or m minus n gets cancelled, or d value is that is 1 by mn. Right, d value is there now. Now we want to calculate the value of a also. So substituting this d value either this equation or in this equation, then from the first equation a plus m minus 1 into d means I am substituting d value 1 by mn, that is equal to 1 by n. Right, or a plus it is 1 by n minus 1 by mn equal to 1 by n. Right, 1 by n gets cancelled, that is a is also equal to 1 by mn. So a value, d value is there. Of course, here a and d are equal. Now coming to our required point, so t mnth term is required. Now I am writing t mnth term. T mn is given by a plus mn minus 1, mn minus 1 into d. This is the mnth term of an AP. Now substitute a and d values from this data. That is a is 1 by mn plus mn minus d is 1 by mn, or 1 by mn plus 1 minus 1 by mn, minus 1 by mn plus 1 by mn gets cancelled. The remaining result is 1. So finally, t mnth term value is equal to 1. T mnth term value equal to 1. Right. In this problem, we are using the nth term of an AP, that is a plus n minus 1 into d. Right. Okay. Second question completed. Right. Coming to the third question. Right. Okay. Third question. We'll go to the third question. The successive terms of an AP are A1, A2, A3, etc. Successive terms. If A6 plus A9 plus A12 plus A15 is 20, some terms is given as 20, then what is the value of course, we require sigma R starts from 1 to 20. That is, we require sum to first 20 terms of this AP series. Sum to first 20 terms. Right. Okay. Now the procedure for third question is, our given data contains AP series terms. That is, you are given A6 plus A9 plus A12 plus A15 is equal to given as 20. This is 20. Here it is, the terms are in AP. Let the first term be A1 and the common difference be D. We are assuming first term and the common difference. Right. Our final target is finding the sum, that is R operates from 1 to 20. That is, we need A1 sum of 20 terms. First sum of 20 terms of an AP. A1 plus A2 plus so on. A20 required. Sum to first 20 terms. Right. Okay. Now coming to here, we are going to calculate the A and D relations. You know, T nth term of an AP is A plus n minus 1 into D. Here A is first term. Our first term is also here A1 plus if you want to calculate A6, that is term 6 is a1 plus n minus 1 into d. Here n is 6, that is 6 minus 1 into d. Let the d is d itself, that is a1 plus 5d is a6 answer. That is a6 is nothing but a plus 5d, a1 plus 5d plus a9 means a1 plus 8d plus a12 means a1 plus 11d and plus a15 means a1 plus 14d equal to 20. I am writing a6 in terms of a1, a9, this is a9, this is the term a12, this is the term a15. Right, now a1 plus a1 plus a1 plus a1, that is 4a1. Now d is 5d plus 8d, that is 13d plus 11d, 24d, 24 plus 14d, that is 38d is 20. Cancelling the common term, common multiples, that is 2a1 plus that is 19d is equal to 10. Is 10, right? Okay, now our aim is calculating the sum to 20 terms. Sum to 20 terms, that is sum to 20 terms of AP is given by, we have a formula sum to n terms, n by 2 into 2a plus n minus 1 into d is the formula for sum to n terms. I am using the sum to n terms formula for calculating this sum, right? Okay, n by 2 is here, n by 2 means 20, n is here 20 by 2, right? 20 by 2 into 2a1 plus n minus 1 into d means 19d. That is 20 by 2, 10. 2a plus 2a1 plus 19d value is 10. That is 10 tens, that is 100. Therefore, this value becomes, this is S20 means sum to first 20 terms value. That is, this sigma value is from the question, that is answer is 100. So we are using the formulas nth term of an AP as well as sum to n terms of AP. Nth term of AP is given by a plus n minus 1 into d, and sum to n terms is given by n by 2 of a plus n minus 2a plus n minus 1 into d are the formulas we are using in this problem. Right? Okay, we will go to the next question. Right. In the next question, the given data is if the ninth term of an AP vanishes means it becomes 0. Then the ratio of its 29th term and 19th term is, given that 9th term of AP is vanishes and we require ratio of 29th term to the 19th term of the AP, right? That is, we are using nth term of an AP here, a plus n minus 1 into d. Let the first term and the common difference of this AP is, let A and D are the first and common differences. You are given 9th term vanishes means 9th term is 0. Vanishes. 9th term, I am writing 9th term, right? 9th term is given by T9 is given by A plus 9 minus 1 into D is equal to 0. A plus n minus 1 into D is 0. 9th term value. That is A is equal to minus 8D. So it is the relation between A and D. Now our final goal is finding the ratio of 29th term to 19th term. That is T29 term 29 to 19th terms ratio. Term 29, term 19 ratio required. I am writing term 29 as A plus 28D is the term 29 and is 2. Term 18 means A plus 19 means 18D here. A plus n minus 1D concept. A plus n minus 1 into D concept. Right. Now replace A with A minus 8D. That is minus 8D plus 28D is to minus 8D plus 18D. Here it is 20D is 2 and it is 10D. So finally the ratio becomes 2 is to 1. So this is the ratio of 29th term to 9th term. Right? Completed. Right. Coming to the next question. That is, in this question, if the sum of 10 terms of an AP is 4 times the sum of its 5 terms, sum of 10 terms of an AP is equal to sum of 5 terms, then the ratio of the first term and the common difference is let the first term of an AP is A, common difference is D. Right. Finally, we require A is to D for this question. But in this question, the given data is sum of 10 terms. Sum of 10 terms means let it be S10. Sum of S10 terms is of an AP is 4 times. Is means equal to 4 times the sum of its 5 terms. Sum of its 5 terms means S5. Sum of 5 terms, sum of 10 terms ratio is given. Right. Now we required finally the ratio of the common difference and first term to the common difference. We require this ratio. Right. Coming to the point S10. S10 is sum to 10 terms. We have formula sum to 10 terms is n by 2 into 2a plus n minus 1 into d is a formula for sum to 10 terms. I am using this formula for calculating S10. That is, A is the first term, n is the number of terms, d is the common difference. S10 is given by 10 by 2 of 2a plus n minus 1 into d. N is here 10. That is 9d is equal to 4 times of S5. S5. Substituting n is equal to 5 here. That is 5 by 2 of 2a plus 5 minus 1 4d. So this is the given relation. Right. Now after modification, it is 5 times and 5 gets cancelled. It is 2 times. That is 2a plus 9d equal to 4a plus 8d. Or 8d, d equal to it is 2a. Of course. So now coming to a is to d required. A is here a itself and d replacing with 2a. So a is to 2a. That is 1 is to 2 is the ratio of first term to the common difference. Right? In this problem we are using sum to n terms of an AP. Again, sum to n terms of an AP is given by the formula n by 2 of 2a plus n minus 1 into d. We are using this formula in this question. Okay, right. Next, some more questions. Right. Okay, students, coming to the next questions. Of course, these are also AP questions. Problems based on arithmetic progression. Now, coming to the next question. If A1, A2, A3, so on, A87, A89, A89 are arithmetic means between 1 and 89, then the value of sigma log tan AR, where R operates from 1 to 89 degrees is. Once again the question, A1, A2, A3 up to A89 are arithmetic means between two numbers 1 and 89. Then finally you have to calculate the value of sigma log of tan AR, where R operates from 1 to 89 degrees. Right. Okay. The given data is 1, A1, A2, A3, so on, A88, A89, comma 89. These are arithmetic means between these two numbers 1 and 89. Of course, this forms in AP series. Right? And then we have to calculate the value of sigma log of tan AR, where R is equal to 1 to 89 degrees. Right, of course. Now coming to 89. Here it is also decreased, nothing but. After expansion, the sigma log tan 80, log tan A1 plus log tan A2. I am expanding the sigma well up to log tan 88 and log tan plus log tan 89 degrees. Sorry, it is A89. It is the sigma expansion. Now log A plus log B becomes log AB. That is log A plus log B plus log C, log ABC. By using logarithmic property, I am expressing all the logarithms into a single logarithm like this. Log of tan A1 into tan A1 into tan A2 into so on. Tan 88 into tan 89. Tan A88 into tan A89. Right. Now coming to the data, if this is AP, then the sum of the terms which are equidistance from the beginning and ending of an AP is always same and is equal to sum of the first and the last. That is A1 plus A89 is equal to A2 plus A88 equal to dash dash is the sum of the second term from the beginning, sum to second term from the ending. This sum and these are all equal and equal to sum of the first and the last, that is 1 plus 89, that is nothing but 90 degrees. That is A1 plus A89 is 90 degrees. We have a property tan A into tan B value becomes 1 if A plus B is 90 degrees. It is from trigonometry. Tan A into tan B becomes 1 if A plus B is 90. Right. Okay. Observe this point. Terms tan A1 into tan A89. I am calculating tan A1 into tan A89 because it is, let it be A, it is B. Their sum is A1 plus A89 sum is 90. Because A plus B is 90, then tan A tan B product is 1. Right. So that's why this product is 1. This product is 1. So all the terms products value becomes 1 because first and the last product 1, second and the last but one product 1. Like that, it becomes tan log of this product is entirely 1. Log 1 becomes 0. Log 1 becomes 0. So finally this answer is equal to 0. So the question is completed. Now coming to the second question. Coming to the next question. Right? Is one of the best question. Next. Second question. In the second question, 100 times the 100th term of an AP with non-zero common difference equal to the 50 times the 50th term of the 50th term. Then the 150th term of this AP is, once again the question, 100 times the 100th term of an AP with a non-zero common difference is 50 times the 50th term of AP. Then what is the 150th term of this AP? Right. You are given 100 times of the 100th term, that is 100th term T100 term 100 times is equal to how many times? 50 times. 50 times the 50th term, that is term 50. This is given relation. 100 times the 100th term of AP is equal to 50 times the 50th term of AP. Then we require 150th term of that AP. Right. We use this formula. Nth term of an AP is A plus N minus 1 into D. Right. Of course, let A comma D be the first term and the common difference of the AP. Now 100 times 100th term, that is A plus 99D is the 100th term, is equal to 50 times the Fifth term means a plus 49d. I am using a plus n minus 1 d here and here. Same formula. Right. Now, of course, this is 2 times. And 2a plus 198d is equal to a plus 49d. That is 2a minus a plus, that is 140, of course 18 minus 149d equal to 0. So according to this data we have this result. Now coming to 150th term, term 150 is a plus 149d is the term 150th term. So a plus 149d is nothing but this value is equal to 0 by data. Therefore this value is 0. Finally term 150th term value is 0 of this AP. Right? Completed. Right. Next, coming to the next question. The sum and the product of the first 3 terms of an AP are 33 and 1155 respectively. Then the value of its 11th term is, once again, if the sum and the product of 3 terms of an AP are 33 and 1155 respectively, then a value of its 11th term is, right, you are given sum of 3 terms and the product of 3 terms of an AP, right, then what is the value of 11th term of its AP, right? That is, sum of 3 terms is given as 33 and their product of 3 terms is given as 1155. Finally we have to calculate the 11th term of the AP. 11th term, that is 11th term is a plus, suppose if a is if a is the first term and d is the common difference, then you have to calculate the 11th term. Here observe that sum of the 3 terms is given. In synopsis we have already discussed, when sum is given, then the selection of 3 terms is taken as, in AP, taken as a minus b, a plus d. When sum is given, then you have to choose or select 3 terms of an AP in this manner. If sum is not given, then choose a plus d, a plus 2d are the 3 terms on AP. When sum is not given, you have to select the 3 terms of AP in this manner. When sum is given, then the selection of terms in the 3 AP is like this. Right, because here sum is given, we are choosing the 3 terms of AP in this manner. Now the sum is 33 means first term, second term, third term, that is AP terms, nothing more. Their sum is 3a minus d plus a plus d, d gets cancelled, 3a is equal to 33. From this data, a is equal to 11. Right, their product means product of these 3 terms is given as this one, that is a minus d into a plus d is given as 1155. That is this value a minus d into a plus d, a square minus d square into a is 1155. A is already there, that is 11 square minus d square into 11 is equal to 1155. Right, 1155. It gets cancelled 105 times, 105. 11 square minus d square is there. Or d square is equal to 121 minus 105, that is d square equal to 16, or d is equal to plus or minus 4. D is equal to plus or minus 4. Here given that the product is given of a number, right? Now d has 2 values. D may be either 4 or minus 4. Suppose in this case if d is equal to 4, if d is equal to 4 and a is equal to 11, then the terms of AP are a minus d. A minus d means 11 minus 4, that is 7. Then a, that is 11, and a plus d, 11 plus 4, 15. These are the 3 terms. when D value is this one, the AP is this must be of the form. You know, first term is 7. What is common difference here? 11. Now you have to calculate 11th term of AP. 11th term becomes A plus 10D. That is, A is here 7. 10 into D means here, A is here 11 and D is 4 and 10D means 44. That becomes 55. A value is first term, that is A value is not 11. These are the data values and our A value is here 11. A is 7 plus 10 into D. D means here 4. That is 40 into 10 into 4 40. The value may be 47. Of course, when D is equal to 4, then 11th term is 47. Then there is another case also possible. The case is when D is equal to minus 4. When D is equal to minus 4, then D is equal to minus 4, then the terms of AP becomes 11 minus of minus 4, that is 15, and A is 11, and A plus D is 11 minus 4, that is 7. Then the AP becomes like this. When D considered as minus 4, then you can calculate 11th term of this AP is T11 is equal to A plus 10D, or A is here 15. 10D means minus 40. Minus 40 plus 15, that is minus 25. So 11th term may be either minus 25 or 11th term may be 47. Both cases are possible because D has two values. Of course, the series may be in ascending order and descending order depending on the values of D. Right? Both the series are in AP with common difference 4. Right? So this question is completed. Next, coming to the next question. Yes, 10. Right. Next question. Let Sn denotes the sum of the first n terms of an AP. Sn notation. If S4 is given as 16, S6 is given as minus 18. What is the value of S10? You know, given S4 is 16 and S6 is given as minus 18. Finally, you have to calculate S10. S10 is required. You know, sum to n terms of an AP is given by, if A is the first term and D is the common difference and n is the number of terms, then sum to n terms is given by the formula n by 2 into 2A plus n minus 1 into D. Is the formula for sum to n terms of AP. Now we are using this formula in this question. Right, here S4 is given as, that is n by 2. N means here 4 by 2 into, let the first term is A and the common difference be D. Right, okay, that is 2A itself plus n minus 1 into D. N is here 4 minus 1 3, D is value is given as 16. I am modifying this equation, that is cancelling the 2 here and 2 becomes here 8 times, that is 2A plus 3D becomes 8. That is the right first equation. Now coming to the second data, S6 is given as, that is S6 is given by 6 by 2, n by 2 of 2A plus n minus 1, 5 minus 6 minus 1, 5D equal to n by 2 of 2A plus n minus 1 into D. That value is given as minus 18. Right? Once again 3 times and 3 here 6 times. Right? That is 2A plus 5D is equal to minus 6. Let it be second equation. Now solving these two equations so that you will get D value as well as A value. If you know A and D, you can calculate S10 easily. Right? So subtracting the second equation from first equation, or second one first. 5D minus 2A gets cancelled. 5D minus 3D, that is 2D, minus 6 minus 8 minus 14. or d is equal to minus 7. D equal to minus 7. Now, if d is equal to minus 7, you can calculate a value from the first equation also. That is 2a 3 into 7 minus 21 equal to 8, or 2a is equal to 29. D value is minus 3 7 21, and it is 8, and it is 29, or a is equal to 29 by 2. Right. Okay, 2d is equal to minus 14, d is equal to, right. Then a value is there, d value is there. Now S10 is given by n by 2 of 2a plus n minus 1 into d. N minus 1 means 9d. That is 5 of 2a. 2a means 29 plus 9d means 9 7 63 minus 63. That is 5 into minus 63. 13 minus 9, that is 4. And 5 minus 2, that is 3, minus 33, that is minus 5 4s 20, 2 5 3s 15, minus 170. It is sum to 10 terms of AP. Sum to 10 terms of AP. Right. Okay, clear? Next, last question. Between the numbers 2 and 20, 8 means are inserted. Then their sum is between the 2 and 20. Between 2 and 20, 8 means are inserted. That is A1, A2. Let the adjoint means be like this. A8. Now, what is the value of sum of the arithmetic means? I am already discussed the standard result. That is, suppose in between two given numbers, if n arithmetic means are inserted, then the relation among the arithmetic means of the given two numbers is given by a1 plus a2 plus a3 plus so on an is equal to n times of a plus b by 2. The statement of this result is sum of the n arithmetic means inserted between two given numbers is equal to n times the single arithmetic mean between two numbers. Once again the statement. Sum of the n arithmetic means between two numbers is equal to n times the single arithmetic mean between two numbers. N times the single arithmetic mean between two numbers. That is, we have to calculate the sum of arithmetic means here a1 plus a2 plus so on a8. Now 8 arithmetic means are there. That is 8 times the single arithmetic mean, that is a plus b is here 2 plus 20 by 2, or 8 into it is 11, or 88. This is the value of sum of arithmetic means which are inserted between 2 and 20. Okay, right. These are some models belongs to arithmetic progression. In the next class, we are going to discuss some models basing on geometric progression and harmonic progression. Okay, we will discuss next class. Thank you.